Welcome everyone to today's lecture on sulfur hexafluoride, or SF6, a critical gas in the electrical industry with a massive environmental footprint. Here, we'll dive into what makes SF6 such a potent greenhouse gas, its impact on our planet, and the eco-friendly alternatives emerging to replace it. Let's get started. Let's begin with the basics. SF6, or sulfur hexafluoride, is a synthetic gas widely used in high-voltage electrical equipment like circuit breakers and gas-insulated switchgear. Why? Because it's an excellent insulator, preventing electrical arcing and ensuring safe operation. But here's the catch. SF6 is one of the most potent greenhouse gases known. Its global warming potential, or GWP, is staggering. 24,000 times greater than carbon dioxide over a 100-year period. To put that into perspective, just 10 grams of SF6 released into the atmosphere has the same warming impact as 228 kilograms of CO2. That's equivalent to the emissions from a typical car driving 1,520 kilometers, roughly the distance from Delhi to Mumbai. And here's the kicker. Once released, SF6 lingers in the atmosphere for up to 3,200 years. It's invisible, odorless, and incredibly persistent. Moreover, SF6 production itself is problematic. During manufacturing, 3 to 8% of the gas can leak, and the process involves exothermic reactions that generate significant heat, leading to additional CO2 emissions. So even before SF6 is used, it's already contributing to environmental harm. So why is SF6 such a big deal for global warming? It's all about its ability to trap heat. The greenhouse effect occurs when gases like sulfur hexafluoride absorb and trap heat in the atmosphere, warming the planet. With a GWP of 24,000, a tiny leak of SF6 can have an outsized impact. For example, that 10 grams of SF6 I mentioned earlier, it's like releasing the emissions of a car driving across a country. This makes even small leaks a major concern for our climate. Now, the good news, the industry is actively seeking alternatives to SF6, and some exciting solutions are emerging. Let's talk about two main contenders, C4FN and compressed air. First, C4FN, often branded as G-cubed by General Electric, or marketed differently by companies like Hitachi, is a fluoronitrile-based gas mixture. It's combined with CO2 and oxygen to create an effective insulator with a much lower environmental impact. While SF6 has a GWP of 25,200, C4FN mixtures have a GWP of less than 716, a massive reduction. Then we have compressed air, used by companies like Siemens, which mixes 20% oxygen with nitrogen. The best part? It has a GWP of 0, making it completely environmentally benign. These alternatives are being adopted across medium and high voltage applications, with major players like GE, Hitachi, and Siemens leading the charge. The biggest advantage of these alternatives is their drastically lower global warming potential. By switching to C4FN or compressed air, we can significantly reduce the climate impact of electrical equipment. For instance, replacing SF6 with a C4FN mixture cuts the GWP by over 98%. Compressed air takes it even further, with no warming potential at all. These alternatives allow us to maintain reliable power systems while protecting our planet. But it's not all smooth sailing. Unlike SF6, which is a pure homogeneous gas, these alternatives are gas mixtures. Their performance depends on precise mixing ratios, temperature, and pressure. This means the internal design of equipment, like breaker chambers, needs to be re-engineered to accommodate these mixtures. Handling these gases is also more complex. With SF6, you had a simple liquid-to-gas phase system. But with alternatives like C4FN, you need specialized service carts with induction systems to control temperature and ensure proper mixing during transfer. Any deviation in the mixing ratio can affect performance and safety. Another challenge is contamination. Moisture has always been a problem in gas-insulated systems, but with these new mixtures, we also have to worry about contaminants like nitrogen oxides, NOx, and sulfur oxides, SOx. Maintaining gas purity is critical to ensuring these alternatives work as intended, but its environmental cost is too high to ignore. With alternatives like C4FN and compressed air, we have the tools to build a greener, more sustainable energy future. It's up to all of us, engineers, policymakers, and innovators, to make this shift happen. Thank you for joining me today, and let's work together to power the world responsibly.
If you found this helpful, don't forget to subscribe, like, and tap the notification bell. Got questions or want us to cover a specific topic? Leave a comment. Thank you.